So last week we were talking about the definition of a logarithm, and I just want to refresh our memory with this. And what happens is with the logarithm, again, I like to write my logarithm on the left. You do not have to. But the reason that I like to do that is that it's easy for me to do what's called around the world when we want to convert this logarithm. So we take the a and we go around. So what happens is that we can then turn this into a to the y equals x, which is what we have up there in the definition, but how did it happen? And it just happened by going around the world. What we also talked about last week is we talked about the domain of a logarithmic function, whether it's log or whether it's ln. The domain is x is greater than 0. This part of the logarithm, sometimes called the argument on the internet, must be positive. If we write this in interval notation, it's 0 to infinity. And what I struggled with on Friday on one of our problems, but we eventually got it figured out, at least I did. I probably confused you all, but the range of a logarithmic function is all reals. And it doesn't matter whether we're dealing with log or whether we're dealing with ln, the domain is coming from the fact that this part of the logarithm must be positive. So our domain is still x is greater than 0, which is negative infinity to infinity, and not negative infinity to infinity, but 0 to infinity.
Negative 0 to infinity?
It's 0. You don't have to have a sign on 0. And our range there is also all reals, which is our negative infinity to infinity. We'll get this out eventually there. The argument, the thing beside the words ln or log, must be positive in our domain. What we're going to look at today is we're going to look at the properties of logarithms. And some of us have more experience than others with this. But there's 3 properties typically that we use. The first one is the product property. And what happens is if we have 2 logarithms with the same base and they're added together, we can condense this logarithm down by multiplying the m and the n together. This goes back to the exponent properties. And I don't know that you should write this down, but if you think about the exponent properties, a to the m times a to the n equals a to the m plus n. So when they're added together, we can multiply, which is really where it comes from.
Oh,
That's where the rule comes from.
so it's all of these are going to be the reverse of
In some regards. So if we look at the quotient, if when we add 2 logarithms together, we multiply, since subtraction is the inverse operation of multiplication, then we can condense log base b of m minus log base b of n into the division. And then thirdly, we've seen this already. When we have an exponent, we can bring that exponent out and make it a coefficient. By the way, this works both ways. If we have log base b of mn, we can expand it to this, or we can have it written like this format and we can condense it. And that works for all of them. So let's use these on our examples here. And the first problem should look remotely familiar from last week's work. And what we're going to do is we have a logarithm on the left. We don't have a logarithm on the right. We're just going to go back and use the definition of logarithm. And all that we're going to do is we're going to take our 2 and we're going to go around the world. So this is 2 to the 4 equals 7x. We would like to figure out what does x equal. Well, 2 to the 4th is 16. Equals 7x.
So then we can divide by 7,
Divide both sides by 7.
and that would get us something around 0.
And I'm going to leave it as 16 sevenths. 2 and 2 sevenths if you prefer a mixed number. But after we get that part done, we need to decide, is this an answer? It says solve each equation using the definition of logarithms and or the properties of logarithms. Remember to check for extraneous solutions. Well, what happens here is that this part of the logarithm must be positive when we take our answer and we put it back in here. So if we take 7 and we multiply by 16 sevenths, will we get a positive number? Yes. So 16 sevenths is an answer. Just as an aside, another way that you could check is we could check the domain. In the domain, we would say 7x is greater than 0. Divide both sides by 7. Is our answer greater than 0? Yes.
So, in that case, log 2 of 16 equal 4?
Yep. And it's true. 2 to the 4th, 2 to the 4th has to equal 16. So 7 times 16 sevenths equals 16.
Okay.
So that's what we worked on last week, and now we'll take a look at more of the property techniques. But the theme that we've been working with throughout Chapter 5 has been like bases. And that doesn't go away here. It's written in a little bit different format, but this is log base 5 of x plus 8 equals log base 5 of 15. We have a log base 5 on the left. We have a log base 5 on the right. We don't need to worry about the log base 5s. So I'm going to cross them out. They don't really cancel out. They just aren't helpful for when we solve these. But because we have one logarithm on the left with a base of 5 and one logarithm with a base of 5 on the right, we can cancel these out and we can solve. So we're left with x plus 8 equals 15. If we subtract 8 from both sides, we get x equals 7. And once we get our answer, we need to check for extraneous solutions. So that means that we're going to go right back here, and that value needs to be positive. In the 15, we're lucky enough we don't have a variable there, but that number has to be positive. When we put 7 back into here, will 7 plus 8 give us a positive number? Yes. So 7 is a solution to our problem. key is we want to have like bases. We want to turn this into one logarithm on the left side of the equation and one logarithm on the right side of the equation. So as we look at this problem, we're going to have to do a little bit more work. And unfortunately, I put this on the back side where you can't see the properties. But the first thing that we're going to look at is this minus right here. And if we flip our papers back over, what does minus tell us that we can do so that we can condense this down into one? Divide. We can rewrite this as log base 2 of x divided by 3 equals log base 2 of 7. And what we did, we put this in a format so that we have one logarithm on the left and one logarithm on the right. So now, we don't need to worry about log base 2. We have like bases. So we can ignore the log base 2's for us to solve. Our goal is to solve for x. So we can multiply this side of the equation by 3 and this side of the equation by 3. And when we do, we end up with x equals 21. And finally, we need to go back and check. Do we have extraneous solutions? Well, the only place that we're looking is right here at the first part of our expression, our equation. If we put 21 back into our function, will it be positive? Yes, it will be positive. We do not have an extraneous solution. Am I going too fast? Problem number 4. Looks complicated. But again, our goal is to condense it down so that we have one logarithm on the left side and one logarithm on the right side. And we're going to use our properties. But we have a couple things to deal with on this one. And the first is that we have a 2 in front of this logarithm. We're going to take this value of 2 and we're going to rewrite it as an exponent. So it's the third property if you look back on your paper in the front. And not only are we going to do that with the 2, but we're also going to do it with the 1/4. Don't take that sign with it, just the 1/4. So when we deal with those coefficients, we have log base 6 of 4 squared minus log base 6 of 16 to the 1/4 equals log base 6 of x. Now we can deal with the minus sign in between, although we can figure out what 4 squared equals here and 16 to the 1/4 equals there. It doesn't make any difference. At some point in time in the problem, we are going to have to figure out those values. So do you want to figure out what they equal now, or do you want to wait for a minute until we deal with that minus sign? Let's do the minus sign. So what does minus tell us to do in the problem? It tells us to divide. So this is going to be 4 squared divided by 16 to the 1/4. We condense this down into 1.
Would it be still 1/4 or be? Because would it 1/4 simply be like -2? Because we already easier to write since we're dealing with exponents.
William, the one thing is, make sure that you're not taking this negative. So you can figure out that 4 squared is 16. And you can figure out that 16 to the 1/4 is 2. You can do it here, or you can do it here. It doesn't make any difference. but don't take that sign. This sign here tells us to divide. But once we get it in this format, what's going to happen then is we have like bases. We don't need to worry about the base. That's not what has the variable in it. We're now left with 4 squared over 16 to the 1/4 equals x. And now we can finish the problem. 4 squared equals 16. 4 times 4. 16 to the 1/4 is the 4th root of 16. Which you could type into your calculator if you would like. You can break it down here, where we need 4 of the same value to take out 1. So we get 16 over 2. 16 over 2 is 8, and there's our value of x. And the only remaining question is that solution extraneous? We always want to at least go back and glance. So we go back to the beginning here. 4 is positive, 16 is positive. When we put 8 in there, is that a positive value? Yes. So no extraneous solutions yet. But it's coming.
Because of course it is.
Oh, it's part of this. Problem number 5. Log of 7 plus log of x minus 2 equals log of 6x. There's no base written. What is it? 10 doesn't have to be written. But we want to condense this down so that we have one logarithm on the left and one logarithm on the right. We've got a plus in this problem. What does plus or addition tell us to do? It's going to be log of 7 times x minus 2 equals log of 6x. Now that we know that, we have a logarithm on the left, and we have a logarithm on the right. They are the same bases. We don't need to worry about the logarithm. We only need to worry about 7 times x minus 2, 6x. And now we're going to solve for x. We're going to distribute the 7. 7x times 14 equals 6x. Subtract 7x from both sides. Get negative 14 equals negative x. And divide both sides by negative 1. So x equals 14. We still need to check for extraneous solutions. And all that we're going to do is we're going to take that 14, we're going to put it back into the problem. We have to put it back in 2 places this time. This value has to be positive. This value also must be positive. Whenever there's a variable in the argument part of the logarithm, that value has to be positive.
So it could not have a negative x because that would make that 6.
So is 14 minus 2, will that give us a positive number?
Yes.
Yes, 12, positive number. 6 times 14, positive 6 times positive 14, whatever it equals is still positive. So our answer is 14. So one minor flaw in these notes that are brand new to me is that I didn't put enough extraneous solutions on these notes. But we are going through the motions of checking, so that's what we need to continue to remember. Problem number 6. Following the same pattern here. And that is, can we condense it down so that we have one logarithm on the left and one logarithm on the right? And when we look at that, we see minus, and what does minus tell us to do? Tells us to divide. Log base 8 of x plus 10 divided by x minus 1 equals log base 8 of 12. We have a log base 8 on the left side. We have a log base 8 on the right side. We can ignore the log base 8s. That is not going to help us solve the problem. We have x plus 10 divided by x minus 1 is 12. Now we want to solve here. So remember, we need to get that x minus 1 out of the denominator. So let's multiply by x minus 1 on both sides. So our x minus 1 cancels out here, and we're left with x plus 10 equals 12 times x minus 1. And then we solve. So we end up with x plus 10 equals 12x minus 12. Distributing that 12. And I'm going to subtract 12x from both sides. And I'm going to subtract 10 from both sides, but you solve it however your Algebra 1 teacher taught you to solve it. So we get negative 11x equals negative 22. And finally, we'll divide both sides by negative 11. We get x equals 2. Question then remains is that solution an extraneous solution? Well, we can never get back up here to the top. When we get our value there, we need to go back in here and make sure that that value is positive. And here, make sure that value is positive. And 2 plus 10 is 12. 12 is positive. 2 minus 1 is 1. 1 is positive. Another quick little thing to remember is that most of your calculators will do this. Alpha window and then function number 5 allows you to type in the base. We can check this. Log base 8 of 2 plus 2 plus 10 minus log base 8 of 2 minus 1 gives us that decimal. And then when we check it to match the other side, log base 8 of 12 we should get the same value. So it's a nice checking technique when you're taking a test or a quiz. And we didn't get an error on the calculator. So if we get an error, that probably means that our answer is going to be extraneous. But we didn't have that situation here. So finally, what does an extraneous solution look like? Because we haven't seen one yet, so it's got to be in here somewhere. And as we take a look at the last example, log base 2 of x minus 3 plus log base 2 of x plus 2 equals log base 2 of 14. Let's continue our pattern. We want to condense it down so that we have one logarithm on the left and one logarithm on the right. What does plus tell us to do? Multiply. It's going to be log base 2 of x minus 3 times x plus 2 equals log base 2 of 14. Well, we have one log base 2 on the left, one log base 2 on the right. We can ignore those. We're left with x minus 3 times x plus 2 equals 14. So now we're going to have to multiply these two parentheses. And we get x squared plus 2x
Plus 2x minus 3x.
minus 3x minus 6 is 14. If we simplify that, we have x squared minus x minus 6 equals 14. Remember, to solve this, we're going to move the 14 over with everything else. So we get x squared minus x minus 20 equals 0. And now we're going to factor. So we have x and x. Factors of 20 are 1 times 20, 2 times 10, and 4 times 5. Will any of those combine to be 1? 5 and 4. And the fact that 5 will be negative. So to almost finish, we're going to take each factor and set it equal to 0. I hope you don't have to do this stuff. I hope you can go directly to the answers. So we get x equals negative 4 and x equals 5. And we need to check both of these answers for extraneous solutions. So we're going to take our values and we're going to go back to the problem, the original problem. And when we put negative 4 in here, negative 4 minus 3 is negative 7, and this value needs to be positive. Well, negative 7 is not positive. Which means that we're going to cross this out. Don't scribble it out. And I usually write EXT by it. That solution is extraneous. The second that we get a negative value, it's out. But we still do want to check the 5, and we go back to the original problem, and 5 minus 3 is 2. Choose a positive number. 5 plus 2 is a positive number, 7. And 14 is already positive. So, this problem, our answer is only 5. If I could get there. But in terms of grading, I look for both these answers and the fact that you can identify that something is extraneous. What you're going to be doing now is you're going to be working on that paper, that stapled paper. The answers are on the back. Please forgive me if I got a wrong answer. I tried to get all the right answers, but it's the first time I've ever used this.